Hi everyone. So this is my video project for 354, and in it I want to discuss one of the prevailing interpretations of quantum mechanics, and that's the many worlds interpretation. I have a bachelor's in philosophy, and so I'm kind of fascinated by the big questions around our current understanding in physics and what our theories might be able to tell us about the nature of reality and what they might not. So first, just to outline the physical system that helps illustrate the weirdness in the Copenhagen interpretation. Uh, We all know by now the canonical experiment for quantum phenomena in which you send electrons through a double slit. And when you detect where the electrons land somewhere behind the slit, you observe a classic wave interference pattern. So Schrodinger devised the wave equation to mathematically formalize the physicals here. And because the wave equation is a differential equation, its solutions can include multiple different wave functions. This is what's known as the superposition principle. So the location of the electron going through the double slit is thought of as a wave interfering with itself, even if it's just one electron. But obviously we don't observe multiple positions for the electron's location when we go to measure it. And so under the Copenhagen interpretation, we postulate that the electron's wave function with many states, quote unquote, collapses to a single state upon measurement. In other words, the act of measuring the electron instantaneously removes the superposition and reduces its wave function to a single part. Now, this is thought to be a problem because nothing in the wave equation indicates why this collapse occurs or how to predict it. So the Copenhagen interpretation says that the universe is essentially random and undeterministic. We have no way of knowing where we'll measure the electron, just that we're more likely to measure it here or there. The wave function only tells us how the probability distribution for where the electron might be in time and space, but that measuring it somehow breaks this function. Okay, so enter the many worlds interpretation, which is first credited to Hugh Everett, a Princeton graduate student in the 50s. Under this interpretation, you can extend the wave equation to our macroscopic universe, which evolves as a unit at the global level. The many worlds interpretation posits that there is no collapse of the wave function. It just seems like there is because, as subjects and observers, we are all just one part of some huge global wave function. So when the electron goes through the double slit, it doesn't go through as a probability distribution, it goes through as its wave function, and it goes through deterministically. This electron here going through the double slit corresponds to all the possible locations in the future where it might be measured, and you here, as an observer, correspond to all the possible observers in the future where you could measure it. What many worlds basically says is that the observer measuring it here and the observer measuring it here are both real. Both states are described by the wave function, and the wave function is real. The reason we feel like we're in one world and not all of the worlds at once is due to an idea called decoherence, which says that a superposition of states can only be maintained through time if the states and their wave functions stay in phase with each other, more or less. Even the slightest interaction with the environment can change this phase relationship between states and lose the coherence of the system. For us as observers, all the quantum states of all the particles that make us up as conscious beings would have to be coherent for us to theoretically observe a superposition. But obviously, we're not in a very delicate, isolated environment, and the time it takes for those states to decohere is practically zero. So many worlds is able to avoid the issue of explaining how the wave function collapses, but it opens up a real philosophical can of worms in the process. It seems kind of absurd that reality would constantly be branching itself uh, into a near infinite number of different worlds that evolve in a shared time. Schrodinger's cat is alive in one world and dead in another, and each possibility sets up a parallel world. We must have all a bunch of barely different selves walking around in some parallel reality then, but I don't think it's actually unreasonable that the many worlds interpretation might be correct. The interpretation asks us basically how much we believe in mathematics. Max Tegmark of MIT has an even more expansive formulation of the many worlds theory, where any mathematically true object must be some reality somewhere. The many worlds interpretation says, like, look, the wave function successfully describes this real thing, so the wave function must be real. Is our reality more than a really complex wave function? And if it is, how so? What can you specify that you can't include in a complete mathematical description of the universe? I don't really know the answer to that, but those are the kind of questions I think are interesting to think about, and ones that might change how we think of our reality in the future.